Today we're going to be talking about graphing linear equations. So if you have your graph paper, you might need to use it. So what exactly is a linear equation? A linear equation is an equation that forms a line when it is graphed. Linear equations are often written in the form of ax plus by is equal to c. This form is called the standard form. In this equation, the c is the constant. This is just a number that is not attached to the x or the y. Both a and b are variable terms. So if we look at the below equation, we have 3x plus 2y is equal to 5. If we're trying to figure out what a is equal to 3, B is equal to 2, and C is equal to 5. This standard form is very important. So we have the next equation. We have x is equal to 7. This is still put in the standard form, even though we don't have a y. We can still this is still written as standard form. In this case, a is equal to 1, because remember, there's always a number 1 in front of any variable. So b is equal to 0, since we don't really have a b. If there's nothing there, then b is equal to 0, and c is equal to 7. So now we want to identify if an equation is linear, if it's in a linear function. We can find it out by two ways. First way, if the equation can be written in standard form, it is a linear equation. It is a linear equation. And the second way, if there is an exponent or multiple variables, it is not a linear equation. It is not a linear equation. So let's look at this example that we have below here. We have y is equal to 4 minus 3x. I want to see if this can be written in standard form. Remember what our standard form is supposed to look like. It's supposed to look like ax plus by is equal to c. So it always has to be in this section, in this way. X has to be first, y has to be second, the constant has to be last. So if we're looking at what we have, y is already on the left side. We want to move this 3x over to the left side as well. So if we move it to the left side as well, if we have minus 3x, the opposite is to add 3x to both sides. So these will cancel. And then if we rewrite it, we could have 3x plus y is equal to 4. So this is written in standard form. We have our x followed by y, and that's equal to our constant. So a is 3, b is 1, and c is 4. So y equals 4 minus 3x is a linear equation. So now we have three examples. I'm going to do the one in the top left, and then you're going to try the one on the right and the one on the bottom by yourself. But let's look at the first one on the top left. We're trying to see if 6x minus xy is equal to 4. We're trying to see if that is a linear function. So it looks like this is sort of written in standard form, where a is equal to 6, B would be equal to X, and C is equal to 4. But B must always be a number. So A is a number with 6, C is a number with 4, but see how B correlates to X? This is not in standard form. This is where there are multiple variables. So for example, we have this X right here, and then we have this X here. This is showing that there are multiple variables. So this is an example of not a linear equation. It's not linear. Alright, so what I want you to do is to pause the video, try the equation on the right and the equation below, and then unpause the video when you're ready to see what I've done. Alright, so the one on the right, we have y is equal to x squared minus 4. Remember, one of the things that I said on the previous slide is if you have any type of an exponent, it is not linear. So just right off the bat, we have our exponent, which means not linear. Alright, so let's look at the one on the bottom. We have 8 plus y is equal to 4x. We want to see if this can be put into standard form. Remember what standard form looks like. ax plus by is equal to c. So it looks like we want to have our x's on the left. So we would have, we could subtract 4x from the left. We could just subtract 4x over there. So now we would have a negative 4x plus 8 plus y is equal to 0. And so we have the x's over here already. We have the y's over here. Now we just need to move the constants over. We need to move this 8 over to the side. So if we subtract 8, our final equation in standard form would look like negative 4x plus y is equal to negative 8, where negative 4 is A, 1 is B, and negative 8 is equal to C. So this is linear. So now we're going to talk about the x and the y-intercept. The x-intercept is the point at which the graph crosses the x-axis. So in the x-axis. So if we look in the example below, the x-axis we have, remember, goes left to right, and it crosses right here at the negative 2. So the x-axis in this example, or the x-intercept in this example, is negative 2. The y-intercept is at the point at which the graph crosses the y-axis. So in the example below, the y-axis is the vertical line, goes up and down. So wherever it crosses on the y-axis, right here at 2, this is the y-intercept. So now we have another example. What I want you to do is to find the x-intercept and the y-intercept. So pause the video and try this one real quick. Alright, so if we have the x-intercept, where does it cross on the x-axis? It crosses right here at the 4, so the x-intercept is a positive 4. The y-intercept is right here at the 2, so the y-intercept is 2. Remember, actually look real quick to see how this is plotted. So if the x-intercept, remember, x is 4. Where is it on the y and where is it on the y-axis? It's at 0 on the y-axis. So this could be written as 4, 0. Now the y-intercept Look where it is on the x-axis. On the x-axis it is 0. Y is 2. So this could be written as 0, comma 2. Now we have a table. We have our x and our y. What I want to find is what is our x-intercept from this table. Remember, the x-intercept is where the line crosses on the x-axis. When it crosses on the x-axis, if we look at coordinate points, the y is going to be 0. So we want to look in the table to see where y is equal to 0. So if y is equal to 0 here, our x-intercept is going to be at -2, comma 0. Now with the y-intercept, we want to find it where the x is 0, and that is what our y-intercept is going to be. So if x is 0, that'd be right here. So our y-intercept is 0, comma 2. These are very important. It might help you to write them down. Now we're going to graph by using the intercepts. So to find the x-intercept, what they want you to do is to let y equal to 0. So let's start off with the x-intercept first. If we start off with the x-intercept, we want y to equal 0. So we can rewrite this equation: 2x plus 4 times 0, because y is equal to 0, that's equal to 16. So basically 4 times 0, that cancels out, because 4 times 0 is 0. So all we have left is 2x is equal to 16. So if we divide by 2, x is equal to 8. So our x-intercept is going to be at x equals 8. So that's the x-intercept. Now to find the y-intercept, they want x to equal to 0. Let x equal 0. So let's rewrite this. So x is going to equal 0. So 2 times 0 plus 4y is equal to 16. So if we have 2 times 0, that's 0, so that basically cancels out. So now we have 4y is equal to 16. Opposite of division is opposite of multiplication is division. Divide by 4. So y is equal to 4. So when we graph this, our y-intercept is going to be 4. Our x-intercept is going to be 8. If for points, it's going to be 8, comma 0, and the other one is 0, comma 4. Because remember, we said x is 0, y is 4. We said that we're going to make y 0 and x is equal to 8. So now we're going to graph by making a table. We have our equation. We have 3x is equal to y. Since x can be any number that we want, we have to, at minimum, put 3 numbers, any numbers that we want, in the x column. So the ones that I'd like to start off with is -1, 0, and 1. So all we have to do, take -1, plug that into x, and then solve for y. So 3 times -1 is equal to -3. So y is equal to -3. 0 times 3 times 0 is equal to 0. So that's another point. Then 3 times 1 is equal to 3. So that's another point. So now we have our coordinate pairs. We have 1, comma, -3. We have 0, comma, 0, 1, comma, 3. So all we have to do, come over and plot the points. 1, -3, 0, 0, 1, comma, 3. Draw a straight line between them. And there we go. And this is the graph of 3x is equal to y.